This video is a review of the Edgenuity lesson Base E. So first I'll just start off in defining what E is. It's a number. It's a button on your calculator as well. The way you find the number E is this expression here as n approaches infinity. So if I plug in the largest numbers that I can think of for n, when you evaluate that, it just gets closer and closer and closer to this number, which goes on forever. So another thing that they kind of touched on in the video but don't really explain is natural log. So when you have a natural log, that's when you have a log base E, and the way you write it as is lnx, and this stands for the natural log of x, where it's log base E. So another thing they don't really tell you, E and natural log undo each other, just like in the other videos that we did where exponential functions and then bases undo each other. They're inverses of each other. So like if I wanted to solve this, if I had e to the power of 2x equals 12, I can't do anything until the e is gone. I can't solve for the x. So what we would do is just take the natural log of both sides. Those cancel, and you would just get 2x equals natural log 12, which is just a button on your calculator. So I would go, mine's right here, natural log of 12, and then divide that value by 2. So the solution there would be about 1.24. So we would divide by 2 at the end. On this one, so we have natural log of 4x equals 5. So these are attached to each other. So to undo the natural log, we would just use base E on both. And E is an exponential function. So these become exponents. So what happens is E and natural log cancel. And so I get 4x equals e to the 5th power. Again, that's just a button on my calculator. It's right there next to natural log. So I would go second. And e pops up. We want e to the 5th power. And then, so this right here is 148.41. The last thing we would do is divide both sides by 4. So x would be 37.1. Okay, so this first example says find the value of e to the power of natural log 2x. So remember, e and natural log undo each other, so those would just cancel, and we just are left with 2x. And then it doesn't equal anything, so there's no solving. Example 2 says express as a single logarithm. So we're going to use the properties that they gave us of logs a couple of lessons ago, because this is still a log, it's just log base E, and to put this together. So we want to combine it so there's only one ln. So the first thing you should do is put any numbers in the front back up as exponents. So I get the natural log of 3 cubed minus natural log 9. 3 cubed is 27. Remember, subtraction goes with division. Addition goes with multiplication. So if I want to put this together and it's being subtracted, subtraction goes with division. And then 27 divided by 9 is 3. Okay, for example 3, it says solve 3 times the natural log of 2 plus the natural log of 8 equals 2 times the natural log of 4x. So just like before, the first thing I'm going to do is that any numbers that are being multiplied in the front, I'm going to put them back up as exponents. So this becomes the natural log of 2 cubed plus the natural log of 8 equals natural log of that whole quantity 4x squared. So 2 cubed is 8. 4x squared, if I distribute that in, we would get 16x squared. So over here on the left, I want to put those together. Addition goes with multiplication. So 8 times 8 is 64. And now that we have one natural log on either side, what we can do is use e. As long as you do it to both sides, you stay balanced. So that cancels and that cancels. And we get 64 equals 16x squared. Divide both sides by 16. And then square root. Remember that when you square root both sides of an equation, you should put a plus or minus in the front. But logs can never be negative. And if I were to plug in -4 right here, we'd have natural log of -16, and you can't do that. So our final answer is just the +4. So when you get to the graphing section, the one thing to note is really just E's shape is like this. So it's on the positive part of the y values. Towards the left, it gets really, really close to 0, but won't ever touch it. And towards the right, it grows very quickly towards infinity. Natural log is a reflection of E over the line y equals x. So this is what its shape looked like. It goes down forever and gets really, really close to 0 on the x-axis, but doesn't actually touch it. And then as it goes to the right, our x values grow really fast. The one thing to note is there is on E a horizontal asymptote here at 0, but if you ever add anything onto it, that asymptote will shift up and down with it. So for example, if we had like e to the power of x plus 2, everything here would shift up 2 units. So this would shift up 2 units, and then my graph would shift up 2 units as well. Here with natural log, it can't, when it shifts left and right, that's when your asymptote will move. So for left and right, remember those are the things that are in the, so if I had like natural log of x plus 1, remember it's opposite for left and right, so we would go to the left one. So instead of our asymptote being here at 0, it would be right here at -1. And our graph would shift to the left as well.